Okay, we're going to talk about inverses today. And sometimes they'll write inverse relation, sometimes they'll write inverse function. And it's because if you remember back in chapter 3, not all graphs represent functions. And we're going to revisit what it means to be a function later. So an inverse relation is when you have a point A, B, or X, Y. The inverse relation contains the opposite. The input becomes the output, and the output becomes the input. So basically, X and Y switch places. Graphically, inverses are a reflection over the line Y equals X. And I'm using this thick marker because I want you to go and get a bold color. And it can't be the thinnest, saddest line you've ever done. It has to be a good, bold line. And I want you to go from corner to corner of your graph. So like so. So I'm going to go like that. I'm going to get it. That's the line Y equals X. And I want you guys to do that on both of them. So take a moment and get that. Okay. So now you can make your lines thinner. What we're going to do is we're going to graph in one color this original, okay? And then we're going to graph its mirror image in another. So I'm going to go to, let's see, -6 and then up 5. That is supposed to be up 5. I'm going to have you fix that. Up 5, right there. Then we have -4, 3, great. -3, 2, 0, 5, and 2, 7. Okay, so I'm going to connect these with a straight line. So I'm going to go here, and then I'm going to make my straight line over there. Okay, well, if we're going to do our inverse, so I'm going to do the original in green, and I'm going to do my inverses in this purpley color. We're just going to switch what we have there. So instead of having -6, 5, we're going to have the point 5, -6. Instead of -4 and 3, 3, -4. Just switch your X and your Y. 2, -3, 5, 0, 7, 2. Now, go and find these points. So if we go over to 5 and we go down 6, here we are. 3, -4, 2, -3, then 5, 0. Oh, so now it's going to curve back up that way. And let's see, 7 would be 2. Okay. Now I want you guys to do something. If you lock your screen, so I'm just going to lock my screen right now. If I lock my screen and I turn my iPad so that this line is vertical, so that it's standing straight up and down, when I do that, the purple and green do look like mirror images of each other. And that's exactly what is supposed to happen. So let's do one more. Let's see if we remember how to, let's go back to our green, how to graph this. Now, for those of you who got on board with the transformations and know that this is just shifting to the left, you can cheat, get your graph and get on over there. But for the rest of us who may have forgotten how to do that, what would it take to make this 0? And it would take a -4. So that's our starting point. That's the end point of the function. So we're going to do, when I plug in -4, I'm going to get the square root of 0, which is 0. Great. We want to plug in good numbers, things that are going to give us like the square root of 1, the square root of 4, or the square root of 9, which wouldn't quite fit on our own graph. So we're going to look for these two. So I'm going to use like -3. If I plug in -3, I'm going to get the square root of 1, which is 1. If I want to make this in here, well, look, if I plug in a 0, 0 plus 4 is going to equal 4. So I want to plug in 0, and then I'm going to get the square root of 4 is equal to 2. So let's plot these points. -4, 0, -3, 1, and 0, 2. I guess we could see what it takes to make this a 9. That wouldn't be bad. A 5. If I plug in 5, I'm going to get the square root of 5 plus 4, which is 9. And I'm going to get 3. So let's plug in 5, 3. Let's just get all 3. Because it'll be good to see what happens when they crisscross each other. Great. So let's go get our purple. You know what to do. We're going to switch these points. So I'm going to write them over here on this side. Instead of writing -4, 0, I'm going to write 0, -4. I'm going to write 1, -3, 2, 0, and 3, 5. If you need to, pause for a second and get these graphed, and let's see if they come out to be what we have here. Now, it is okay if they cross each other. If you're like, oh no, they crisscrossed. Yeah, that's supposed to happen. 1, -3, 0, and we didn't go to -4. Great. And now we have this curve. And they cross perfectly. And again, if you lock your screen and you turn it so that this line is vertical line, it's standing straight up and down, they will look like mirror images of each other. You're going to pause this for a moment. You're going to take a break for a moment and do a few problems that have to do with graphing inverses, and then you'll come back and do part 2 of the notes.